Hi, this is Mrs. Mays. Welcome to our podcast, The Wave Nature of Light. You see, understanding about light and waves will help us to understand about matter, because in 1905, Einstein derived an equation that helped us to relate matter and energy. It was the first time anybody had ever linked the two. For a long time, thought they were simply two separate entities, but Einstein said, no, they're actually related. And you've probably seen this equation before. Remember what Einstein said? E equals, right, mc squared, where E is the part that represents energy, and m is the part that represents mass. And then this quantity c, we're going to get very familiar with. This one is the speed of our light wave, or speed of light. And that's it. So basically he's saying if mass is destroyed somehow, it turns into energy. We'll talk more about that in class. This equation described a relationship between matter and energy for the first time in history. Before then, like in the 1600s, there was no agreement on what light really was. So Isaac Newton said light is a particle. But another scientist, Huygens, said, no, light's not really a particle. We could describe light more like a wave. So which scientist do you think was right? Well, I have a video for us to maybe try and understand, because then Thomas Young did an experiment that appeared to settle the argument. Notice this was not until 1801, and Newton was working in the 1600s. So it took a really long time for them to try and come up with a good explanation. Let's hear what these guys have to say about it.
What is light?
What is light? What is light? That's a good question, isn't it? What is light?
Isn't it an element?
Light?
Yes, they are.
It lights up the room. It makes it not dark.
What's the difference between blue light and red light?
The colour.
It goes in your eyes and then you see stuff.
If I was to explain it to a blind person, right,
yeah.
it would be the difference. You see nothing whatsoever as a blind person, whereas I see things in front of me.
To be fair, the question of what light is not an easy one. For centuries, the greatest minds in science debated this issue. In the late 1600s, Newton proposed that light was a stream of particles, or corpuscles. He proposed this in his treatise Optics. But at the same time, a Dutch physicist named Huygens proposed that light was a wave. And this debate raged on until it was settled by the experiment I've recreated today, Thomas Young's double-slit experiment. To make sure I got the experiment right, I went to the original source. With the help of Brady Heron, I managed to get into the vault underneath the Royal Society in London. There I found Thomas Young's handwritten notes from 1803.
I brought into the sunbeam a slip of a card, about 1/30th of an inch in breadth, and observed its shadow, either on the wall or on other cards held at different distances. Besides the fringes of colors on each side of the shadow itself was divided by similar parallel fringes of smaller dimensions. Wow.
This is an experiment so simple that you could make it at home, and yet so fiddly that I have never seen it before done with sunlight.
I was thinking about doing it in a box, like a fridge box.
And you could take it out on the street.
Taking it out on the street.
Could I possibly interview you guys for about a minute? We're doing a science experiment. What I have here is an empty box. And this is a little eyepiece where we can look in, and this is a hole. And I'm going to place this slide above that hole. And if you look closely, you'll see that there's two openings. Very narrow openings side by side. It's a double slit. Now before we have a look, we need to tilt it towards the sun a little bit. So we want the sun to hit this double slit directly. What are we going to see on the bottom
Well,
of the
the obvious
box?
thing you think you're going to see is you're going to see two lines.
2 lines on the bottom of the box. 2 bright bands.
Two little lines.
Yeah.
I think it'll be one line instead of two.
I could expect to see the whole box lit up.
It'll probably be a kaleidoscope of some sort.
A bunch of colors.
Probably, yeah.
Rainbow, different colours.
There, have a look. You expected to see kind of one line. Is that what you see?
No.
I see dots.
How many?
It's one circle.
Oh, there's one in the middle strongest, two either side.
The two on the outside are multicolored. The one in the middle is just white.
It's kind of a rainbow.
The rainbow of colour as well. Quite a few colours and lots of little dots.
Like there are more dots appearing.
I think I can even see more dots spreading along. Yeah, that's amazing. Yeah, I can see tons of dots now. Not tons, but I can see dots spreading across that way.
Either side.
Yeah, definitely.
Isn't that amazing?
Yeah, that's incredible. And that's just nothing else apart from
Two slits.
two slits. That's incredible.
But all we're doing is we're putting a light through two very narrow slits side by side. So how does this make any sense?
There's some kind of principle involved there that the average person's not familiar with. That's the only explanation.
No, I'm really confused by it, but I'd like to find out why.
People were debating, is light a wave or is it made of particles?
So what causes that?
Well, if light were behaving as particles, you would expect them to go through each slit and just produce a bright spot underneath. So we would see two bright spots on the bottom of the box. But if light's behaving as waves, then the wave from one slit can interact with the waves from the other slit.
So what we see in the double slit experiment is that light clearly behaves much like waves do. Newton wasn't entirely wrong either. His suggestion that light acts like a particle was based on reflection and refraction of light. You know, when light hits a mirror, it bounces back. But after Young's experiments, most scientists were convinced that light must be a wave, and it was a pretty convincing argument.